Hello, and today's purpose of the day is I can factor and solve quadratics in the form of ax squared plus bx plus c equals 0. So as you can see in the picture, the problem that we'll have today with factoring quadratics is that we'll have a coefficient in front of x squared that will be something other than 1. The only thing that we have factored before, the only trinomials in the form of x squared plus bx plus c, have been with a coefficient of 1. So again, today we will see a coefficient of something that is other than 1. So for our first example, we are going to factor 12x squared minus 5x minus 2. So I have color-coded what each coefficient stands for. So 12 is A, negative 5 is B, and negative 2 is C. So we're going to use what's called the snowflake method to factor a quadratic trinomial if there is no GCF or the GCF has already been factored out. The coefficient in front of x squared A is not 1. So again, we are going to use the snowflake method, which will look like this. So it looks like an asterisk in that we have the x right here that we've already been using, but now we're going to add one more line, and so that looks like a snowflake. That's why I call it the snowflake method. On the top of the snowflake goes A times C. So 12 times negative 2 is negative 24. So that's what will go on the top of our snowflake. On the bottom, we just put B just like before. So here it's negative 5. And again, on the top of our snowflake goes A times C, which we came up with was negative 24 for this example. Now, in the bottom two spaces, we have to think of what are the factors that multiply to be negative 24 but add up to be negative 5. So this is very similar to what the diamond method was like, but now we just add one more step, and we'll talk about what goes in these two spots finally at the end. But again, think about what multiplies to give us the top number, which is negative 24, but then again adds to get to negative 5, which is the bottom number. Again, if you're struggling to come up with factors, I encourage you to list out the factors of negative 24. That would be helpful. Or use your calculator and go through the factors of negative 24. So, do you see any that would work? That would add up to be negative 5? Well, what about if we change this 8 to a negative 8 with the 3, and that would multiply to be negative 24, but then at the same time add to be negative 5? So we have found our factors in 3 and negative 8. So again, this was factors of negative 24, and that should have been a negative 8 there. So I'm going to put both of my factors in the bottom spaces. Doesn't matter what side they go on. I could have put the 8 over here and the the negative 8 over here and the 3 over here, but it really doesn't matter. Then to fill out the last parts of our snowflake, A goes into the top spots of your snowflake. So we have our whole snowflake filled out right now. Now we have to look at what we need to do to actually figure out our factors and solve the rest of this problem. So on the two sides, we are going to look at these fractions. So my 12 over 3 and my 12 over negative 8 are fractions that form our factors. So with my two binomials, you can see I've written out two binomials with the variable x in them. I'm going to simplify my fractions on the sides. So 12 over negative 3, if I take a 3 out of them, it becomes 4 over 1. And 12 over negative 8 becomes 3 over negative 2, and it's very important to keep the negative with where it should be. It's on the bottom here with the negative 8, so it needs to stay with that 2, and that's very important because I'll show you how in just a moment that forms our factors. So we got 4 over 1 and 3 over negative 2. So that's what we put into our factored form. So I will write into my factors 4x plus 1. So again, that fraction will just go right down here. And then this fraction, my 3x minus 2, goes right down below. So I just use exactly what I have for my fractions to form my factors. So here's another picture. Again, the 4 over 1 makes 4x plus 1. The 3 over negative 2 makes 3x minus 2. Now we can check our work here when we get our end result in our two binomials. We can go ahead and FOIL and make sure that we get with the original product that we started with. So I will multiply here. 4x by 3x is 12x squared. 4x times negative 2 is negative 8x, plus 3x minus 2. If I put my middle terms together, I get 12x squared minus 5x minus 2, which is good because that's what I started with and that's what I wanted to factor. So now let's look at another example. Negative 4x squared plus 13x plus 12. Over here I've drawn in the snowflake for you to fill in if you need to again, but just to remind you of what goes where. So the first thing we have to do here is that I see it starts with a negative, right, a negative 4, but I actually need to get rid of that first, otherwise it's very difficult to factor. The 4 can stay there, but the negative we need to get rid of. So if I factor out a negative 1, I simply change all the signs of my trinomial. And again, we do have to factor out that negative 1, otherwise we get into a lot of problems. So I factor out the negative 1, we'll just add that into our answer at the end. So now I'm going to make my snowflake. In the top goes AC, 4 times negative 12, which is negative 48. On the bottom goes B, which is now positive 13, right? We changed it by factoring out that negative 1. Then up on the top spots goes 4. Let's write that a little bit better. And now I have to ask myself, what are factors of negative 48 that when added together give me 13? Well, again, it's helpful to list out the factors or have a calculator next to you, but they would be 16 and negative 3. And again, it does not matter the sides I put my two factors in or where they go. And now I'm going to simplify my fractions on the sides. And 4 over 16 simplifies to 1/4. And 4 over negative 3 can't simplify, so that just stays as it is. So now, when I write my factors, I have my negative 1 in my answer. This first fraction over here of 1/4 turns into x plus 4. 1x plus 4, but I don't have to really write the 1, doesn't matter. And then my second fraction right here would be 4x minus 3. So this should be my answer, but let's double check it by foiling. So I'm going to FOIL these two binomials, then add in the negative 1 at the end and multiply each term by negative 1. So x times x is 4x squared minus 3x plus 16x minus 12. If I put together my like terms, I get 4x squared plus 13x minus 12. But now I'll take that and multiply it all by negative 1, because again, I factored that out, so I got to keep that in my answer. And negative 1 times 4x squared is negative 4x squared. Negative 1 times 13x is negative 13x. Negative 1 times negative 12 is a plus 12. So let's look back up at the top here. Is that what I started with? Negative 4x squared minus 13x plus 12 is right. So we know that this is our final answer. Well, excuse me, that's not the final answer. That's the final answer was right up here in that, right here, in that we have negative 1, I'll rewrite it down here so you can see it better. Negative 1 times the quantity, x plus 4, 4x minus 3 would be the factored form. Now let's take a look at the third example. So again, I see a negative 4x squared plus 5x minus 12, so that negative 1 I need to factor out right away. So then I get 4x squared minus 5x plus 12. And let's fill in our snowflake. So on the top goes AC, and 4 times 12 is 48. On the bottom goes B, which is negative 5. And on the top two spots goes 4 and 4. So now you have to ask yourself, what are the factors of 48 that when added together give me 5? Well, 48 divided by 2 is 24, and that can't add up to be 5. 48 divided by 8 is 6, but that can't add up to be 5. 48 divided by 12 is 4. Those two together can't find a way to make up 5. 48, let's keep trying factors. Divided by 16 is 3. That can't add up or subtract to get 5. Do you think this is even possible? It's not possible. So if you cannot factor a trinomial with any method, in here we're using the snowflake method, we would write prime. So that means like any number like 5 is only divisible by 1 in itself. Any prime number is only divisible by 1 in itself. Just like this trinomial, it's only divisible by 1 in itself. So therefore it is prime in that it's already in its lowest factored form. Here's an extra example that I added in. So let's look at factoring 12x squared minus 2x minus 24. The reason I wanted to go over an example like this is because when you look at this problem, 12, 2, and 24 already has a GCF in it of 2. So let's factor out a 2 right away. And then when we factor out a 2, we get 6x squared minus x minus 12. And now we're going to use that to use the snowflake method on. So let's take a look at this. What goes on the top is a times c. And here a times c is negative 72. What goes on the bottom is negative 1, which is b. Up on the top would be 6. And factors of negative 72 that when added together give me negative 1 are negative 9 and positive 8. And now we look at simplifying our fractions on the side. 6 over 8 can simplify to 3/4. And 6 over 9 can simplify to 2 over negative 3. So when I write out my factors, this 2 that I factored out has to be written in my answer. So I'm going to get 2 times the quantity, 2x minus 3, and that came from my first fraction there. Then my second fraction turns into 3x plus 4. So this would be my final answer. So again, a big thing that I wanted to talk about was take out a GCF if possible first. It will be so much easier to factor and work out, and if I would not have taken out that 2 right away, this would have been a lot harder to factor, and you would have then had to simplify at the end, which is a little bit difficult to do. So it's always easy to take that out right away at the beginning of the problem. Now let's take this a step further and let's solve. So number 1, let's zoom in here. And I see 2x squared plus 9x plus 9 equals 0. So the first step is good in that it's already equal to 0. Second step is we look to take out a GCF, and we don't have one. So let's go ahead and label A, B, and C. Now I'm going to set up the snowflake method. And I'm going to say factors of 18, that when added together give me 9, and 2 goes on the top. And I have to find factors of 18 that when added together give me 9, and I get 6 and 3. So 6 and 3, and then I will look at my fractions here, and I'll try to simplify them. I can simplify the one on the right. 2 over 6 simplifies to 1/3. So my factors are x plus 3 times the quantity 2x plus 3 equals 0. So now I have to set both of these equal to 0, both factors. So I'll kind of write them in different colors. So I'll set x plus 3 equal to 0 and solve for x and get x equals negative 3. And now I'll set my other factor right here equal to 0. 2x plus 3 equals 0. And subtract 3 and get 2x equals negative 3. Divide by 2, so I get x equals negative 3/2. So my two solutions here, and I'll put them in bracket form, would be negative 3 and negative 3/2. So again, what we just did there is we solved this quadratic equation. So if we were to plug them back in, we know that the equation should work out, and it should work. So let's plug in negative 3 just to test one and check it, right? Because we wanted to figure out what you could plug in to make this equation equal to 0. So if I plug in negative 3, here I'll show us a little bit more work down here. I would say 2 times negative 3 squared plus 9 times negative 3 plus 9 should equal 0. So negative 3 squared is 9, and 2 times 9 is 18, minus 27 plus 9. So 18 minus 27 is negative 9, plus 9 does equal 0. So we're right, and we could do that same thing with negative 3/2 and plug that back in. But just to save a little bit of time, I'm going to go on to the next example, and that this problem does work out. And so our answers are, negative 3 and negative 3/2. Okay, let's look at number 2 here. So as I look at number 2, the thing I noticed first is that I have to move the 20 over. So I'm going to add 20 to both sides so that this equation can get equal to 0. So I see 3x squared plus 17x plus 20 equals 0. And I can't factor anything out, so I'll go ahead and make my snowflake. Find factors of 60 that when added together give me 17. And that would be 12 and 5. And then I look at my two fractions and I say, okay, how can I simplify them? Well, 3 over 5 can't be simplified, but 3 over 12 turns into 1/4. So my two factors are 3x plus 5 times 1x plus 4 equals 0. So I have to solve them both here. So if I set 3x plus 5 equal to 0, and sometimes you get better, you can do these in your head, that will be negative 5/3, and then this one will be negative 4. And those would be my two solutions. And again, if we're on a target check or quiz or a test, you'll definitely want to plug your answers in and make sure that they work. Okay, let's look at the last example here. Ooh, so I see a 10x on the wrong side, so I need to move that to the other side to get my equation equal to 0. And I get 3x squared minus 10x plus 8 equals 0. Make my snowflake method. Factors of 24, that one added together give me negative 10. And this can get tricky because there's lots of factors of 24 that you could think to add up to be 10, like 6 and 4, 12 and 2, but you do have to get the right ones, and we have to be mindful of the signs. So let's look here. Factors of 24 that would add together give me negative 10. So I need a positive 24, but a negative 10. So I would think here this would be a negative 6 and a negative 4. And then I can simplify this one over here to 1 over negative 2. So I get x minus 2, and then this other fraction here cannot be simplified, so 3x minus 4 equals 0. Then I would set them both equal to 0, so I'll show my work on this one. Again, if you can do them in your head, go for it. I'll add 2 and get x equals 2, add 4, and then eventually divide by 3. So then I get 4/3. So my two solutions here are 2 and 4/3. And again, I should be getting 2 answers for all of these equations, and hopefully you remembered this, but because I have a quadratic equation and that my degree is 2, the exponent is 2, so I should have 2 solutions to quadratic equations, or at least the ones that we are practicing with right now. Thanks for listening. Have a great day. Bye-bye.